Good morning, everyone. Today I will be presenting a detailed technical talk on finding duplicate, which is one of the most important engineering challenges in modern data driving systems. Duplicate detection plays a critical role across several domains. Introduction. Duplicate data plays a critical role across the several domains. For example, database. It relies on duplicate detection to avoid redundant entries. Big data analytics need a duplicate-free data sets for clean and accurate results. In cybersecurity, detecting repeated threats patterns is essential to prevent attacks. Cloud storage systems like Google Drive and Dropbox use reduplication to avoid storing identical files and multiple times. In machine learning, removing repeated training samples is important to prevent modeling bias. So, these are the main types. If duplicates are not detected properly, it can lead to serious problems such as wrong outputs and inconsistent results and data corruptions and increased memory usage and higher storage cost and incorrect or biased modeling training. So, duplicate detection is not just a programming task, it is a core engineering necessity across the industries. And second one is problem formal problem statement. Formally, we can represent the problem as follows. Given a data set is equals to D is equals to D1, D2, D3, D4 and so on and Dn. The goal is to find all elements that appear more than once. This dataset can be of any type, structured like SQL table, semi-structured like JSON or logs, unstructured like images, videos and audios. The problem becomes harder when the data is too large to fit in memory. The data arrives as continuous stream and environment is distributed. There is noise, missing values or inconsistencies. Additionally, we must handle constraints like memory limitations, time limitations, and network and cluster constraints. This makes duplicate detection a complex engineering problem, not a simple coding exercise. Why it is a complex engineering problem? There are five main reasons why duplicate detection becomes complex at scale. So, the five are scale of data, speed requirements, variety of data types, distributed environments, and fault tolerance. So, let us discuss scale of data. Scale of data is nothing but modern organizations generate terabytes or even petabytes of data per day. Storing everything in memory is impossible. So, second one, speed requirements. Some systems need millisecond level duplicate detections. For example, fraud transaction must be caught instantly. Server logs may generate millions of events per second. And third one, variety of data types. Duplicates are not only text, they may be images or sensor logs or network packets or audio or video, which type needs a different detection techniques. And fourth one is distributed environments. Data is stored across multiple servers. Duplicates must be detected across the entire clusters, not just within a single machine. And fifth one is fault tolerance. Nodes may fail. Even if one machine crashes, the system still correctly identifies duplicates. All these constants make the problem significant engineering challenge. Change. Naive approaches and their limitations. Naive approaches and their limitations. The most basic method of detection of duplicates is brute force method comparison method. How it works? Compare each element with each other element in the dataset. If anyone matches is found, it marks as duplicate. Illustration for dataset of n is equals to 10 lakhs elements. Total comparison is equals to n into n minus 1 by 2 is equals to 4, 99, 999 and 500 and 000. Complexity. Time complexity is equals to O into n square. Extremely slow for large data sets. Space complexity 0 into 1. Uses, more, uses almost no extra memory. Why it fails? To slow the modern systems. Fails when the dataset grows beyond a few million items. Cannot support big data platforms, real time systems, and cloud scale systems. So, brute force method is good for teaching but not for real engineering students. Efficient approach. First one is hashtag. Hashtag is one of the fastest and most partial ways to detect duplicates. How hashtag works? A hashtag stores elements such that look up like 0, 1, in intersection 1. While scanning data, if the element is already in the hash set, duplicate is found, else it inserts it. Complexity. Time is equals to n and space is equals to n. Advantages. It is very fast, no sorting required, good for both structured and unstructured data, and works well in real-time validations. Limitations are requires memory propagation to detect dataset size. For massive dataset like billions or entries, memory may be insufficient. Risk of hash collisions, rare but possible. Real world applications, compiler symbols tables, and banking systems to detect duplicate financial transactions, and web servers to avoid redundant logging. User registration system to prevent duplication accounts. API late remitting. HashPower almost all real-time duplicate detection engines today. Efficient approach. Sorting method. Sorting the array like compare the neighbors. Step 1. Sorting data. Compare AI with AI plus 1. Matches duplicates. Complexity is time is equals to n log n and space is equals to 1 if in place of sort. Where it is used when data must be processed with offline when memory is limited. And eighth one, advanced method like bloom filters. Bloom filter is a provided data structure. Advantage extremely memory efficient, works on huge streaming data sets and zero table negatives. Disadvantages possible false positives and cannot count exact numbers. Used in Google Big Table and CDN and network thread detections. And ninth one is distributed large scale duplicate detection for massive data like local algorithms fail. Distributed frameworks like Handloop Map Reduce and Apache Spark. Map Reduce approaches map match sledge image key 1 and key with count 1 duplicates. Handles TB and false element and horizontally scalable. File and image duplicate detection. Christopher hashing used to detect exact copies like MD5, SHA1, SHA256. If two files have same hash, identical content, used in cloud storage, backup systems, and version control. Used by Google Photos, Facebook, Instagram, and Pinterest. And audio video fingerprinting used for identifying music or video duplicates even after pinching change, cropping, and compression. Case study 1, Cloud Storage Reduplication. Cloud perform platform like Google Drive and Dropbox face huge storage cost. Problem, millions of users upload similar files. Solution, compute hash of each upload and compare with existing hashes if same stores only one copy. Result, reduces storage by 30 to 40%, saves millions of dollars annually. This is one of the most successful application of duplicate detection. Case study 2, Banking Fraud Detection. Bank must detect duplicate of suspicious transactions. Like example, repetition of same transaction and duplicate of check processing and multiple accounts with same identity. Solution, hashing, indexing and machine learning analogy detection. Case 33, AI dataset cleaning. AI models fails if trained or repeated samples. Problem, large datasets may contain thousands of duplicates images or and text samples. Solution, perpetual hashing and future vector comparison and KNN clusters, ensuring a clean dataset lend to better unbiased modeling performance. Challenges and future scope. Current challenges, data privacy issues, noise data, high memory requirements, distributed system failures. Future scopes, AI based reduplication, automated similarity detection, improved Bloom filters, edge computing reduplication. The field continues to evolve as data size increases. Conclusion. To conclude, duplicate detection is an essential engineering requirement in almost all the modern systems. It improves data quantity, accuracy, storing efficiency, and system performance. It is also heavily in big data analytics, AML, and cloud computing, cybersecurity, and bank managing. A robust duplicate detection system must be efficient, scalable, fault tolerant, and intelligent. Thank you.